Number 10. Suppose the total cost C of x in dollars to manufacture a quantity x of weed killer in hundreds of liters is given by the function C of x equals x cubed minus 4x squared plus 7x plus 60. Where is C of x decreasing and where is C of x increasing? Well, to determine that, we take the derivative. C prime of x is 3x squared minus 8x plus 7. Now, if you try to factor this, you're going to find out that it won't factor. So our only alternative is to go to the quadratic formula, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So the opposite of b is 8, plus and minus the square root, b squared, 64, minus 4 times a, 3, times c, 7. All of that is over 2a. So when we simplify that, we get 8 plus or minus the square root of 64 minus 84. And of course I forgot to put my a in there, so that'd be 2 times 3 is all over 6. Now look what happens here. We have a negative under the square root. See, this is negative because that's negative 20. That means there are no real numbers where it's 0. So there are no zeros that are real. And since we're talking about the real world and not working with imaginary numbers, we have an open number line here. And so what we have to do is just decide if that derivative, that 3x squared minus 8x plus 7, is positive or negative. Okay, so if we plug in any value, such as 0 minus 0 plus 7, we end up with 7. So it's always positive. The rate of change is always positive. Therefore, the function is always increasing, and choice B, the function is never decreasing, is our answer to part A. So where is it increasing? Well, it's increasing for all values of x. So from negative infinity to positive infinity. Number 11. A manufacturer sells video games with the following cost and revenue functions in dollars, where x is the number of games sold. Determine the intervals on which the profit is increasing. So the first thing we need to know here is that the equation for profit, or P of x, where x is the number of units of games in this case, is your revenue from those games minus your costs from those games. So our profit is going to be 0.792 x squared minus 0.0002 x cubed minus the entire cost function. So I'm going to put parentheses around it to remind me that I'm going to need to change the sign of those terms inside the parentheses. So I'm going to get out my calculator, and I'm going to combine my x squares. So I've got a 0.792, and from that I'm going to subtract 0.18, and that gives me 0.612 x squared. Now I've got a minus 0.0002 x cubed and a minus minus, which means a plus 0.00008 cubed. So it's going to be 0.0002, and it's negative. Add to that 0.00008, and that gives me minus 0.00012 x cubed, and that is simply the profit function. Now we have to take the derivative. P prime of x is 0.612 times 2, so 1.224x minus 0.00012 times 3, 0.00036 x squared. Now we have to take this and set it equal to 0. 1.224x minus 0.00036 x squared equal to 0. So there are a few things I could do here to make this a little bit easier to work with. One is to see if I can factor out a common factor, which obviously I can factor out an x, because they both have an x. I could also, in order to find the zeros, I could also move these decimal points the same number of places to the end. So I would need to move them both 5 places, so I would get 1, 2, 2, 4, 0, 0, because I got to move it 3, 4, 5, so I need the 2 zeros. X minus 36 x squared equals 0. And I'm kind of hoping 36 will go into this. Let's see. 1, 2, 2, 4, 0, 0 divided by 36 goes exactly 3,400 times. So that means I can factor out a 36x, and I'll get 3,400 minus x equals 0. This gives me 2 relatively easy to solve equations. So x is 0 for the first one. 3,400 minus x is 0 if x is 3,400. So my 2 possible points for where the function changes from increasing to decreasing is at 0 and at 3,400. Now at this point, it should start to make sense that x can't be negative, because x is the number of games sold. So I don't need to look over here. I need to find out if it's increasing in here between 0 and 3,400, or if it increases from 3,400 and up. So that's to plus infinity. So I take my derivative, which is this. Let me take a clip of it. And I need to evaluate it between 0 and 3,400 and to the right of that. Okay, so I'm just going to evaluate it at 1, because that's going to be in between there. So the profit derivative at 1 is 1.224 minus 0.0003 X. Well, that's going to be a positive number. So this is positive. In this first region, it's increasing. So we know it's here. Now, it could also be increasing here. So I'm going to have to pick another number to the right of that. So I'm going to pick P prime of 10,000. That's going to give me 1.224 times 10,000 minus 0.00036 times 10,000 squared. So this one is going to give me 12,240, because when I multiply that by 10,000, it's just going to move my decimal point. So 1.224 times 10,000 is 12,240. Now over here I have to do the square first, so I've got to do 10,000 squared. That's pretty big. That's 100 million times 0.00036, and that gives me 36,000. And that's going to be a negative overall. So our change in the profit is negative in the region from 3,400 to plus infinity. So the profit is increasing between cells of 0 and 3,400. And of course, you're not selling anything at 0, but 0 is not included. So it would be at 1 unit would be where the first profit is earned.